Let me have them. I'm so frustrated. I'm not ready for that test though. Holy cow. I haven't even that any of it.
He's like, well, I was up last year, so he's make a move.
Okay.
It's like the questions are so like oddly specific.
Ready for the weekend?
Wait, the month is this due today? Wait, today's not the next.
No, I have a very big doubt and I need your consult.
Oh.
Do you like homeworks? Are you okay if we give full grade for this one and just go right to the next one?
Yeah.
I just mean, okay? Yep, you're
Yeah.
approving.
Yes, absolutely.
So we'll consider that. I'll show the key right now because I miscounted the days and it will be way behind the material. And it's so
That's what I needed today.
Friday.
well, maybe you'll do another one on the day, but it will be easier and it will be a different one. So we will just,
That's fine.
and total number of homeworks will not increase. Just
It makes me so happy.
so since it was fallen on my side for miscounting, so everyone gets full credit for this one. But I invite you just to follow what the key. Okay, so first question was to what it, right? Yes?
Good question.
Okay.
You don't have class on Monday the 11th?
What?
We don't have class on Monday the 11th.
Oh yeah,
So how do you want us to?
We got a presentation.
No. Presentation is whatever, fourth.
Is
Yeah,
Monday.
coming
This one.
Monday.
This is the next Monday, which.
Oh, okay.
Yeah.
Is it completely day off?
Yes.
Yeah.
For Veterans Day.
Oh, okay. Very good. Very good.
I forgot about that.
So do you want to
Wednesday
do
or do you want us to
Wednesday
like-
the 13th?
It's better. I do not think you want to do it earlier. You probably
I
want to do
think
it
that
later,
would
right?
be a really good idea to do it later.
Okay.
Let's add that.
Yeah. Thanks. And yeah, mark it as.
I was just like, all right, sounds good.
Yeah, life should be easy, not much stress. So just put the function, which is finding where. So if here is number 3, it means the third excited state, and it should have how many humps? 4, right? So in order to draw a function without a computer, we find where this polynomial equals 0. John is not here right now, but we are following his testament. Putting x out of brackets, so 1, 0 will be at 0, and then we solve this for values of x, right? So it will be x squared of 3 over 2, and then there will be 3 points where it intersects. So the linear intersects at 0, and this quadratic function intersects here, and then we need to multiply it. When we multiply it, it will be like cubic parabola that intersects in these 3 points, and when we multiply it by Gaussian function, it will be decreasing to 0, right? So everyone is getting credits. If you are very much into math rather than the physical chemistry, probably it's called Rodriguez formula. So if one practices derivatives, like if there is no derivative, it will be 1. If you take first derivative, it will be minus x. If you take second, it will be x squared minus 1. Then this, so if you repeat pattern of the polynomials, that will help to build eigenstates of harmonic potential, right? And I have no doubt that you all take derivatives easily. Another question for me. Oof. This one is not quite correct because, well, not so much applicable to what we need because, no, it is applicable because when we do creation operator, we have I factor itself and another I from definition of momentum. And when one does multiplication by linear function and derivative, there will be three terms, same as we did in class last time, right? And these x squared terms add together with the same sign, and you get 2x squared minus 1. So it is the same thing as we did in class, just a little easier without Born constants. And if one now look how fun it is. Bless you, bless you, bless you.
Thank you.
Isn't it? So you did minus sign here, right? And you got ramped up from linear to quadratic. If you do plus sign here, which will be annihilation, then this x squared will cancel each other, and one will get ground state stuff, right? So our original hypothesis, by applying creation and annihilation operators, we jump between like one ladder up, one ladder down, is still not proved, but all evidences that we see are agreeing with it, not contradicting. So when one room up, one room down. Okay, everyone is getting credit. What if we multiply these things by each other? So if one carefully opens the brackets, there will be x squared and minus second derivative, right? First and last. And in the middle, there will be derivative and position, position and derivative, right? And it is one of the, a little, I wouldn't say much counterintuitive, but new thing that I was not expecting when coming first time into the class on physical chemistry, that swapping stuff is not for free, one needs to pay for it. So here they are coming with different signs, which means it is a commutation of derivative and position, which, and we know that one needs to substitute an unknown function and practice derivative, and it will be this unknown function at the exit, right? Which means this commutation is 1. So the product of these two things will be x squared, which looks like potential energy, second derivative, which looks like kinetic energy, and it will be another term. So in addition to kinetic and potential energy, there will be something else. If we just multiply things that look very much like creation and annihilation derivatives, right? So if these two guys are our Hamiltonian, then Hamiltonian will be equal product of creation times annihilation minus additional term or whatever, plus additional constant, right? And this additional constant that will be added to the left and right. This additional constant originates from the fact that position and momentum do not have mathematical. And practically, it will mean that even if our position and momentum have 0 values, the ground state energy will be above 0, 0 point energy. So it is not trap that's being set up by people. It's just happens naturally by rules of games that we already accept. So through this commutation nature of positional momentum, it comes that the ground state will have non-zero energy. Oh, okay. I was threatening you with this question, but now you're getting credit for it. So 6 examples of oscillators. Vibrating atoms, vibrations of over solvent, ball and spring, plasmons and nanoparticles, radio contour, forming capacitance conductivity, and electric field and lasers. I think this one was suggested by Steven. Last meeting, there was a voice from above telling me, you have forgotten oscillations of electric field. And I will play, I think we are done with your homework, right? And this is this thing that I skipped last time for normalization, that we already assumed as completed for this one of us where we will use it. And if one needs to take these integrals like 0, 2, and 4, it will be a little easier if one also tries to practice this I1, because here one can submerge the independent variable and the differentiation, and then it will be the same here and there. Don't focus. I'll tell you when to. But if one takes all these integrals like pi square root of pi, 2 square roots of pi, 3 square roots of pi, and one gets them together and makes this balance, it will come exactly to what you did to take this integral, one needs to practice integrating by parts. So to my memory, this xi squared can be considered as xi times xi, and then xi times Gaussian function xi is something that one can take, and then one swaps the order by creation of parts. Now it's time to wake up, at least for me. You still, please do not give too much strength and exhaust yourself. I'll tell when it's something real, but I need to wake up and recall who we are and what are we doing. In some sense, the coming 2 meetings, 2 lectures, well, 3. Now, the one on Monday will be your presentations on MATLAB skills. And the one that I present today and on Wednesday will be preparatory to complete this homework that you already did. So if you look through this homework, you will get an idea that it will be somewhat connected to finding matrix elements. I think it is your most hated subject from particle in the box, right? So because it's not too much complicated, but it is, and I do not think it is much counterintuitive, but it is not traditional in what we are doing in other classes, neither in like science or math. This is relates to conversion from differential operators, which are already abstract by themselves, into matrix. And the idea is that for any differential operator, there is a matrix representation, right? The things that you are doing in the lab, in MATLAB, everything is matrices, but those matrices in the lab are just discrete representation of coordinate space. And as we want to be more precise, we add more and more grid points which are denser and denser, and we go to continuous limit. But there is a truly discrete limit when we express an operator in basis of eigenstates, or some good basis states, right? Maybe in 631G basis. It's also basis set, just three-dimensional. Now we are speaking about one-dimensional basis. Why? We're in physical chemistry, we predict outcomes of measurements, we are practicing wave nature of electron, applying it to simplest models. So, why we need to find matrix elements of operators? Because we don't want. But if we are inside the logic and enclosed logic of the course, what is the necessity to find matrix elements? I have no doubt that you know the answer. It just takes verbal effort. So the goal is to predict observables. Observables are always expectation values.
We kind of like use the matrix or like the pattern
Mm-hmm.
in the matrix to like predict the outcome of different
observables for specific quantum states of the model, right? So if the model is in arbitrary quantum state, we will get results of measurement. Expected value will be summation of matrix elements with different proportionality coefficients. But most complicated, well, if you do things with computers, it doesn't matter. It's just a little more or less numerical effort and time and power if it is something complicated. But if you do it by hand, it's like terrible amount of work that any normal human wants to avoid. And finding this expectation values with for new wave function again and again is a pain. If one can find these matrix elements and then express outcome as they're adding them together, it saves time. We appreciate it less with advent of strong computer power, but at least we make life of our fellow robots a little easier. So even for computers, it will be less numerical effort. So I think we did not bad in finding, like in previous chapter on particle in the box, we did not bad in finding expectation values of position operator, especially for diagonal. They were just L/2, right and middle point. For transition or for off-diagonal elements, it was a little more complicated, but we also did it. For momentum, I think we skipped it in grading, but it is a little more challenging but doable. We are going to practice the same direction with the same logic for harmonic oscillator. I know it is all what we do is a little bit above the average expectations for such course, but if we want to describe real life, we will need to go into time domain. And time domain is not quite possible without these things. So, which operators need to be processed with the concept of expectation of matrix elements? Probably the same, right? Position, momentum, what else? Huh? Matrix element of evolution. Yes. Good idea. What else? Very good. And energy will be composed of matrix elements of kinetic and potential energy. Good. And kinetic and potential are for the oscillator will be just momentum squared and position squared. Enough? I know that the less the better, but can you imagine what I can find? Which other operators we did play with in this section, in this chapter? Hamiltonian is total energy. But which other operators we did practice? Yes. So look at this. Ladder operators are linear superposition of position and momentum. Then if we overcome our natural laziness, we can do inverse transformation and express either position or momentum as linear superposition of accretion and inflation. Then it is like interchangeable. If we know matrix elements of position and momentum, we know matrix elements of accretion and inflation, and opposite. If you know matrix elements of creation, I'm tired of speaking, of creation and inflation, then automatically you know matrix elements of position and momentum if you know this layer of transformation. Why? Why we are torturing each other with so much new concepts and information? You'll not believe it because of laziness. If you really set up these goals and try to cover this path, I'm making my best possible effort to minimize the efforts. And if instead you already experienced that it is possible, but a little exhausting to look for matrix elements of position and momentum in your particle in the box experience. The same for oscillator. But if we go through ladder operators, all matrix elements will be 5 times quicker to find, and it will take a little barrier to come to a counterintuitive component that will, as soon as we complete it, it will be very logical, very quick, very consistent with itself. So if you consider a chance to be excited with this course in general, the part about this ladder operators, their matrix elements, and could be something pleasant to your to the logical part of the brain. So I don't know why I told you this. Here is the math. Probably just a little motivation. So what was the take-home message from our last meeting on Wednesday? I can flip the slide back. This way. So this is our take-home message from Wednesday, and it reads that application of creation of related to understanding of oscillator will give the next state times a factor of square root where the number of new states is coming here. Suppose I want to practice. I want to do a little mathematical experiment. I want to multiply this from left by pi sub m and integrate. If you complete this operation, it will be basically the only thing for today's meeting, minus my verbal exercises to explain motivation. So on the left, we are not going to do anything. We just are going to call it matrix element M A plus N, right? What do you do on the right? Does square root of n plus 1 depend on independent variable x? Do we have liberty to put square root of n plus 1 out of integration? What is the result of integration of two good quantum functions of m and n plus 1? Huh? No. So if you want to please our best friend with a special gift on a birthday in form of mathematical functions, and this friend wants to judge are they good or bad functions, what is the criterion? For basis functions or for eigenstates? Which property should they obey?
I remember, I just can't.
You can.
Not there.
It is there. Human brain is like a little library with a lot of drawers locked by keys, and there is a little library archive man running around, opening different drawers. And if memory doesn't serve well, it means this man just can't find the key. But all things are there. Yes, one if the indices here and there are the same, and if they are different. Huh? The right word is orthogonality. If you would say this word, I would assume that I would abandon the rest of the quotations. Orthogonality, what is it? Huh? Either one or? Yes. Perfect. So if the indices for and here I have forgotten to put this. So if functions, they are both depending on x, I'm just not writing it because of extreme laziness. If m equals n plus 1, the result will be 1 times the square root of n plus 1. If m is not equal to n plus 1, the result will be 0. So I would write it here as equals square root n plus 1, if m equals n plus 1. 0 if m is not equal to n plus 1. That's it. We are not going to get anything else in today's meeting. We're just going to chew this expression open it from different angles.
Is that's not a star, that's just like an x, right? So like 5x, not 5 star of n. It's just that?
I know we are opening fun club of my calligraphy.
Oh,
This one is star.
okay.
It's not a number. It's just symbol of conjugation.
Oh, well, I didn't know if it was x, like 5x.
No.
But if it's star, okay, I will write that.
So if it would be m equals n and m not equal n, it will be like delta function. And delta function corresponds to matrix which has ones on main diagonal. But if there is n plus 1 here, then on the main diagonal will be zeros. But it will be ones or either above or below diagonal. And I'm not intelligent enough to say where. You can check it by looking at the English. But in addition, this matrix with ones on the main sub-diagonal are also multiplied by this n plus 1. So they will be ramping up and getting bigger and bigger. And there is nothing new. I'm not making setups. It follows from stuff that we found last Wednesday, and this stuff follows from careful practicing of normalization. So it's just natural property of this creation operators, right? So it's quite simple and quite symmetric. And the beauty of this thing is you didn't practice much of hands-on computation of matrix elements. You did maybe 8 of those, like 4 for position, 4 for momentum, but I will be not surprised to learn that you're very tired, exhausted, and started to hating this procedure. Okay? So there is reason to find them, but it's vague. And here, through just one operation, we found that most of them are zeros for this operator, which is an achievement. And you already know the answer for all of them. So you have the infinite matrix and you know its values. You already found this matrix out. And it will be a very similar thing for annihilation. And if you add them together or subtract, we will get position and momentum. So in some sense, we already done. We found what will be the position and momentum. So instead of taking these functions with exponentials, polynomials, putting x, integrating, which will take maybe an hour for each matrix element. And if you need like 3 by 3, 9 elements, which is requested in the homework, it will take like for the first matrix without this hint, it will take like 9 elements, 9 hours. It's something that we are not looking forward to with all your busy schedules. And this one, you just plug in the values and fill this matrix within 3 minutes. So I think it is sufficient motivation. Okay, let me explore if we have more slides. Yes, so we did this stuff. Do you see connection? So we requested m equals n plus 1. Right? Delta functions means that it will be square root n plus 1 comma if m is equal n plus 1, and it will be 0 if m is not equal to. Right? Just repeating the same thing. There are people who practicing such things on a regular basis. If there is motivation to do it, it's still human nature to minimize effort. So in direct notations, this integral that you just took with your knowledge of orthogonality can be written as bra times k. Factor goes outside of the brackets, then you have bra m times ket m plus 1. Just not to induce questions about star symbol. And this notation, if m and if this bra and ket symbolize good basis functions, then naturally they are expected to follow orthogonality. So B1 if these two indices coincide, B0 if they do not coincide. So you have a good chance to catch me not lying, but making unintentional errors. I always forget where those things are going. Let me tell as I remember and I think correct, but you may find otherwise. Be careful with a double check. So if you do not have this clause, if it is Degger, we are going to write down what you found, n plus 1. So if n equals 1, plus 1 will be square root of 2, subdiagonal. If we already requested that this weather operators should be Hermitian conjugation of weather operator should give an opposite operator the opposite action. Just adding Hermitian conjugation to equation operator will give annihilation. And conjugation means transposing of a matrix, right? So it should be upper subdiagonal form. There's also square roots of this stuff. And I think checking whether it will be square root of 1, 2, and 3, or square root of 2, 3, and 4 will be the main part of your question number 1. If you find it wrong, you check that.
So
Yes.
Top left part of the matrix.
Wait. Top left. Navigating. Top left here or top left there?
That's right. Top left.
Oh, top left. Top left.
Okay, so it doesn't go any like higher than that, right? Because
It's
go below
so this
zero.
one will be transition from ground state to ground state.
Okay.
You cannot jump lower than ground.
Yeah, that, okay. And then
And
the
here
rest
we can
is
go
like-
from the ground to the first. Then we cannot go from the ground to the second. We can go from the first to the second.
Okay, and then it goes on forever. Not
Yeah, forever. So this dots symbolize that it goes forever. Yes.
So, are square roots both like coexisting above and below?
No, it's either or. So it's either lower subdiagonal or upper subdiagonal. In all the following comment is very optional and second. Don't listen. All operators that correspond to true observables from the real world are Hermitian, which means conjugation, Hermitian conjugation of realistically existing operator will give this operator itself simultaneously. Simultaneous Hermitian conjugate. The annihilation equation operators, they are not Hermitian conjugate. If you do Hermitian conjugation, it will give the other thing. Because this creation and integration create accentuation, array, are not observed. They are auxiliary abstract quantities. Nevertheless, they are very helpful in solving real problems. So there is no instrument that directly gives you expectation values of creation and integration. But there are instruments that give expectation values of superposition, of operation plus. I don't know, I think I'm done. Let's look what is. Let's browse just a couple of slides, but this. So if it is our definition of equation and integration, we can add or subtract these two things, equations. Then by adding them together and dividing by a factor, should give the x, right? So we already discussed it. Since creation and annihilation operators are defined as linear superposition of position and momentum, then one can design an inverse transform and design position and momentum as a linear superposition of creation. Okay. here we are, right? What I've told is that, huh? A without plus plus A with plus. Divided by square root of mass and frequency. I may have forgotten the one constant somewhere. But then it will give the answer. And if one subtract them, then there is some factors per given number. Yes?
The value for A plus will be higher than the value for A, so it's going up the ladder. So how would you subtract it up? I get if you make your A like somewhere up the ladder, where A plus is like, but if it's ground state.
Wait. If right now we are practicing just algebra,
Okay.
and we are claiming that it will be operator of either position. Position and momentum are defined in respect to equilibrium position. Deviation can be either positive or negative, and momentum can be positive. So having negative values shouldn't be a problem. No. It's right. I see the point of.
I mean, even if you have a higher state.
So the logic is like, suppose we are sitting like up the particle harmonic oscillator is sitting in the excited state number system. What will be its position? What will be its momentum? Yeah. Momentum 0 in position. So diagonal element will be 0. And if we have, if it is simultaneously 50-50 in third and fourth state, due to the stuff we will find. Hello, please come in. We have a class you can join. We will be done before 12. For sure. So if you create superposition, which means like it's half excited, half not excited, same as for the box. Remember this exercise where we put 50-50 in ground and excited. Then there will be chance that both position and momentum will stay. And both position and momentum will be taken positive and negative value. So I completely understand that because we are speaking in the phases of eigen states, then we convert to position and momentum which are like continuous. But the question is, if we are in discrete states, what will be the measurement of continuous variation? And measurement, and it is important to measurement and at a certain time, but the outcome of the measurement will be not stationary, it will change. And it is, so we are scrolling back to the month forgetting everything. Just very first minutes. There is accumulation of phase. And accumulation of phase happens with different phase. Phase with different phase, with different excited states. And it accumulates continually. So if we add together different quantum states, which we are allowed then and then try to find matrix elements, there will be something changing continually due to continuous accumulation of the phase. And although our states, we can get interesting continued dynamics only with two quantum states. So there are two discrete quantum states, but the expectation value will be changing continuously, not just discrete values. This and that. Does it address?
Yeah.
Yeah, let's stop here. Right? So So your a little heading to your you can just 2 minutes walk.